Hello everyone, I'm here to talk about section 8.3 on the homework, and this is for finding a confidence interval for a mean, and this is question number 1. And I have a table here of looks like quantitative information. This is the percentage of women receiving prenatal care, and so all of these are numerical values. And they're taking these percentages from a random sample of countries. So if I read the paragraph, it says the table below contains the percentage of women receiving prenatal care in 2009 for a random sample of countries. Estimate the mean percentage of women receiving prenatal care in all countries in 2009 using a 94% confidence interval. So our level of confidence is 94%. These are all quantitative or numerical pieces of data, and so we're going to find a confidence interval for a mean percentage. And I have this whole list of data. Now, I'm going to do this problem first using StatCrunch because it is much easier to copy and paste this entire data set, and it looks like I have over 30 data values into StatCrunch. Okay, so I've got this list of data. I'm going to copy that and put that into StatCrunch. So for the acronym for finding a confidence interval, it's PANIC. The P stands for parameter. What is the correct parameter? Well, we have a mean, so population mean is mu. What is the wording for this parameter? In the context of this problem, it would be the mean percentage of women receiving prenatal care of all countries in the year 2009. Assumptions. Since we have quantitative data, because these are numerical values, we need to check the following. Was the original population normal? It did not state anything about the population or the distribution of these percentages to be normal. But if the sample size is bigger than 30, and I believe I have 38, so I have 38, so I want to check that the sample size is bigger than or equal to 30, or it's a normal population. It did not state that the distribution was normal, but I do have more than 30. I need to check that there's no outliers in the data set, so we'll use a modified box plot to do that. And of course here, sigma is not known. That means the standard deviation is unknown. And this is what normally happens. Rarely would you ever know the population standard deviation. So we're going to check those assumptions. Well, sigma is definitely not known, which is the modified box plot. So I'm going to now go to StatCrunch. And here, I've actually entered the data set into StatCrunch ahead of time. So I just did a copy paste. I'm going to go to Stat. We'll go to T statistics because we do not know the standard deviation. And we'll go to one sample. And then we do have data. So I'm going to select what I called percent receiving prenatal care. That's just the title I gave the data points. And we're doing a confidence interval. The problem wanted 94%. And before I actually get to the confidence interval, they did want a box plot to see if there are any outliers. So I'm going to select box plot. We'll compute this really quick. And so if I put my cursor over the box plot, the lower limit 72.73, the first quartile is 86.3, the median is 92.47, the third quartile is 95.8. So if I go over here, this last graph is second to last graph. I'm going to line these up here. All right, So I've got these values here. I'm going to hover over this again. And since the first quartile is 86.3, we can eliminate the top graph on the left. That leaves only the bottom 3. Hover over the graph on the right again. The third quartile is 95.8. So that eliminates the second graph. So now I'm only looking at the bottom 2. The median is 92.47. And so that is the last graph. Okay. The key thing is there's no outliers. Otherwise, there would be isolated dots outside of these whiskers. So there's no outliers. Are there any outliers? No. The modified box plot shows no outliers. The sample size is 38. Over this, it does not, it gives the number of values, there's 38. So the sample size is 38, and 38 is bigger than or equal to 30. And so we've satisfied the criteria. No outliers, 38 is bigger than or equal to 30, and sigma is not known. All right. Now it says, is it reasonable to assume the population is normally distributed? Yes, that's why we check those assumptions. Not necessary to check since the sample size is at least 30. Okay. Now if we would have had 20 in our sample, 16, 10, 29, we would actually have to check the normal probability plot to see if it was roughly linear with no outliers. But we don't have that. So it's like this. Name of the procedure, T interval for 1 mean. So T interval. Interval and the point estimate. So now I'm just going to go to StatCrunch. Just going to move this over. I'm going to get rid of the graph we had. Now I'm going to go to Stat, go back to T statistics, 1 sample with data. Select that column, and we want a 94% confidence interval. And now we're just going to click on give us the graph of the confidence interval. I'll move this over here. Okay, the sample mean is 90.13. So the symbol and value for the point estimate is the sample mean. And it wants 3 decimals. So we have 90.131. If we round to the 3rd decimal location. 130, that's the 3rd location, but I look to the right, it's a 5. So I'm going to round to 131. The interval estimate for the population mean is, and it wants to round the endpoints to 3 decimal places and use units exactly as stated in the problem. So I'll first put in the numbers here, 87.565. And I'll check the lower limit there. There's 5 in the 3rd decimal. Look to the right, it's a 3, so it's upper limit is 92.695. There's a 6, so I'm going to round the 5 to a 6. So this would be 92.696. Now it does want the units here, and so we'll go to the units. Estimate the mean percentage. So the units they wanted was percent. The mean percentage is between 87.565%. I can't type right now. To 92.696%. Just give me examples of words to enter here, and we have percent. Conclusion, we are 94% confident that the mean percentage of women receiving prenatal care of all countries in 2009. Okay. Is between 87.565, and now I'm literally just copying the numbers down, percent, and 92.696%. And notice there's the upper limit of the confidence interval, there's the upper limit in my conclusion, there's the lower limit in my confidence interval, there's the lower limit in my confidence conclusion. Notice it actually gave me the units percent, and we have that in both locations. And that completes an example from 8.3.